Hi everyone, this is Sambaraj, Aptitude Trainer, Institute of Aeronautical Engineering College. Today we are going to see one of the most important topic in Aptitude, that is permutations, combinations and probability. In permutations, combinations and probability, a probability it is not a separated. Probability exists in a permutation and probability exists in a combination. Here important only what is permutation and what is combination and what is the difference between permutation and combination. If we know this logic, then permutations, combinations and probability completed. Here complete this chapter using only two principles. One is either using NPR concept or using NCR concept. Here complete this chapter depends only two methods, either using NPR principle or using NCR principle. Here NPR is nothing but P indicate permutation and C indicate combination. A permutation is nothing but arrangement and combination is nothing but selections. The difference between permutation and combination. Here permutation is nothing but repetitions are allowed is called permutation and repetitions are not allowed is called combination. Suppose let us take two-digit number. A two-digit number is equal to 12. If you reverse the digits 21, if you reverse the problem, this meaning is different is called permutation. Here 12, 21 both are different numbers is called permutation. That is AB, BA both exist is called permutation. AB, BA, here order is manner. But combination, repetitions are not allowed is called combination. Either consider AB or BA. Anyone exist is called combination. Suppose let us take two persons or two colors. Here white color, blue color, white, blue. Change the order, blue, white. If you change the order, meaning is same. If you change the order, meaning is same is called combination. Here white, blue, blue, white, but meaning is same is called combination. Here combination means order does not matter. Either consider AB or BA. If the problem is belongs to permutation, next to apply the principle NPR. Here NPR is equal to n factorial divisible by n minus r factorial. If the problem is belongs to combination, apply the method NCR. NCR is equal to n factorial divisible by n minus r factorial into r factorial. This is about permutation and combination definitions. In next third definition in permutations, combinations and probability. In final definition probability. But generally probability P of B means probability of an event is equal to N of E by N of S. Here probability concept is very simple. Here probability of an event is equal to number of events by N of S. Here S indicate sample space. Sample space means all possible outcomes is called sample space. N of E is nothing but number of events. Either exist a permutation or exist a combination. If rate denominator is equal to total, that problem automatically convert into a probability. Here probability it's not a separated. Probability exists in permutation and probability exists in a combination. If the problem is belongs to permutation, then probability is equal to N of E by N of S. Here N of S is nothing but total number of arrangements. Here S denotes sample space, all possible outcomes is called sample space. But if the problem is belongs to permutation, means arrangement, n of s is nothing but total number of arrangements. The primary duty, given information, first we calculate either a permutation or a combination, right? Denominator is equal to total, that is called is equal to probability. Similarly, probability in combination, here n of e is equal to number of events or number of selects. Denominator is equal to, denominator is total number of selections. S is nothing but, permutation means total number of arrangements. Combination means total number of selections. This is information about permutations, combinations and probability. If you know this information perfectly, then minimum 1 mark, maximum 3 marks will come from only campus placements, also competitive exams. Next permutation concept, permutations, combinations and probability definitions completed. Next part, problems in permutation. Here first model in permutation. Here permutation concept. Here permutation means arrangement using the method NPR. Here first model in permutations. Here first question, how many ways the word can be arranged? Example number 1, flower. Example number 2, optical. Example number 3, letter. Example number 4, corporation. Here method very simple. Here either using NPR or using logic of the topic. You can apply any one. Here first method without using formula, using logic method. Here permutation definition, repetitions are allowed is called permutation. That is important here. Here first question, flower. Here flower, here calculate total number of arrangements. Here first sub question number 1, calculate total number of arrangements. Here total number of arrangements means, here flower, a numerator and a denominator, logical approaching method. A numerator and a denominator, total number of arrangements is equal to, a numerator count total number of letters in flower. Total number of letters in flower is equal to 6 letters. 6 letters arranged in 6 factorial. The numerator is equal to 6 factorial. Next denominator, if the problem is belongs to permutation, denominator always you write repetition of letters in flower. Here permutation is nothing but repetitions are allowed. Denominator always write repetition of letters in flower. But in flower there is no repetition letter. Denominator is equal to 1 factorial. So total number of arrangements is equal to 6 factorial divisible by 1 factorial. 6 factorial is nothing but 6 into 5 into 4 into 3 into 2 into 1 is equal to 720. 720 by 1 is equal to 720. Here first one answer is 720. Here 720 correct answer. Here next second one. Second one optical be arranged. Second example, here two models exist in first model. Here first model, repetition of letters, repeated letter, non-repeated letter. First question, second one, first one, second one. These two belongs to non-repeated letters. Third one, fourth one, repetition letters. Here next second one, here optical be arranged. Again same method, same as first method. Here just here to calculate is just here to calculate only total number of arrangements. In numerator is equal to count total number of letters in optical. A number of letters in optical 7 letters. 7 letters arranged in 7 factorial. And denominator repetition of letters in optical. There is no repetition letter is equal to 1 factorial. So answer is 7 factorial divisible by 1 factorial. It's 7 factorial is 7 factorial means 7 into 6 into 5 into 4 into 3 into 2 into 1 divisible by 1 factorial. 1 factorial is equal to 5040 is equal to right answer. Here answer is 5040. Once again, first question and second question logic. Total number of arrangements is equal to numerator and denominator. Numerator count total number of letters and denominator always you write repetition of letters. But first question, second question, there is no repetition letter. Therefore, denominator is equal to 1 factorial. So, first one answer, a 6 factorial is equal to 720. Second one, 7 factorial means 5040. That is right answer. Here next, third question and fourth question. Here condition, repetition of letters. Same method. Same method. A letter. Here first numerator count total number of letters. 1, 2, 3, 4, 5, 6. 6 letters arranged in 6 factorial. And denominator, repetition of letters in letter. E is equal to 2 times is equal to 2 factorial. A T is equal to 2 times 2 factorial. Therefore, total number of arrangements is equal to 6 factorial divisible by 2 factorial into 2 factorial. Here 6 factorial is 6 factorial means 720. 2 factorial into 2 factorial. 2 into 2 is equal to 4. 720 by 4 is equal to 180. Answer is 180. Once again, third example method. Here same concept. Total number of arrangements is equal to numerator count total number of letters in a letter and denominator repetition of letters in a letter. The denominator in letter E is equal to 2 times. T is equal to 2 times. Denominator 2 factorial into 2 factorial. 6 factorial is equal to 720. 2 factorial into 2 factorial is equal to 4. 720 by 4 is equal to 180. Your third answer is 180. Here same as fourth concept, also same method. Again consider repetition of letters in corporation. Here next fourth one, same method. First here same method. A numerator count a total number of letters in corporation 11. 11 letters arranged in 11 factorial. Denominator in corporation O is equal to 3 times 3 factorial. R is equal to 2 times 2 factorial. So answer is 11 factorial divisible by 3 factorial into 2 factorial is equal to answer. This is about total number of arrangements in permutation concept. Here are two methods applicable. First method, non-repeated letter. Second, repetition letters. Here next, second model, model number 2. Here model number 2. Here model 1, there is no event condition. Model number 2, we have event condition. That event condition is all the vowels always come together. Please. The second model, important. Here first example. How many ways the word can be arranged such that all the vowels always come together? First question, optical. Here once again, your event condition, vowels always come together. Here next, and also find out probability. The probability exists in permutation and probability exists in combination. Suppose this question find out probability n of e by n of s. N of e, vowels always come together. That is called event condition. N of s, total number of arrangements. That is model number 1 method. Here model 1 divisible by model 2 is equal to probability. Here first we calculate permutation. That event condition is optical, all the vowels always come together. Your method, short method, a shortcut method. Your condition is applicable only vowel. Here first you have to calculate total number of vowels in optical. In optical, total number of vowels is equal to 3. Total number of articles, total number of vowels in optical, only 3 vowels OIA. Here method. Here together type of questions are given in permutation. That condition always write one bracket. In optical, total number of vowels is equal to 3. 3 vowels, write one bracket. Next, number of consonants in optical, PTCL. Number of consonants only 4, PTCL. In next, event condition, vowels always come together. Together means only one letter. This is considered as a one letter, treated as a one letter. Count total number of letters. Total number of letters is equal to 5. 5 letters arrange is equal to 5 factorial. 5 letters arrange in 5 factorial. And next case 2. Here number of vowels is equal to 3. 3 vowels arrange in 3 factorial. So that answer is all the vowels always come together is equal to 5 factorial into 3 factorial, and denominator always you write a repetition of letters in optical. In denominator there is no repetition letter. Denominator is equal to 1 factorial. So answer is 5 factorial is equal to 120. 3 factorial is equal to 6 is equal to 720. Answer is 720. Here once again method very simple. Here second model in permutations. How many ways the word can be arranged such that all the vowels always come together. Here clearly event condition is given. First model there is no event condition. Calculate permutation of all events, that is permutation of all arrangements. But second model, event condition, all the vowels always come together or consonants always come together. The type of questions are given. Apply the method. Your method is very simple. First given word you divide 2 parts. First part consonants, second part vowels. A number of consonants is equal to 4 and vowels is equal to 3. A next method, case 1 and case 2. Your condition is applicable only vowel. Your vowel together means one letter. This is treated as a one letter. Count total number of letters 5. 5 letters arrange in 5 factorial. And number of vowels is equal to 3. 3 vowels arrange in 3 factorial. And denominator, if the problem is belongs to permutation, denominator always you write repetition of letters in optical. There is no repetition letter. Denominator 1 factorial. Here 5 factorial is equal to 120. 3 factorial means 6. 120 into 6 is equal to 720. If 720 is equal to answer. Suppose same question, find out probability. Suppose example, find the probability that all the vowels always come together. Find the probability that all the vowels always come together. A probability method P of E. Here P of E is equal to N of E by N of S, where N of E number of events. Here event condition, vowels always come together. Above solution is called N of E is equal to 720 and denominator N of S. N of S is nothing but total number of arrangements. That model already completed. First model in permutation. Total number of arrangements in optical. Total number of arrangements in optical is equal to 7 factorial. Then probability is equal to 720 by 7 factorial means probability. The only permutation is equal to 720, but same question find out is equal to probability. Probability answer is 720 by 7 factorial. then at a time permutation completed and also probability completed. Here probability is very simple, but here important only calculate permutation and combination. That is only important, but not probability. And first to find out permutation or a combination, right, denominator is equal to total. A total number of arrangements in optical, 7 letters arranged in 7 factorial. Therefore, probability is equal to 720 by 7 factorial is equal to probability. Right, all these question, first one, second one, third one, fourth question. If you want to probability, right, denominator total number of arrangements by using first model concept. Okay, here answer 720 optical, all the vowels always come together. Second one, flower. How many ways can the letters of the word flower be arranged so that all the vowels always come together? Same method. Here first target, given what you divide two parts. First part, number of consonants in flower, so number of vowels in flower. Number of vowels in flower, OE, only 2 vowels, write one bracket, OE. Next, number of consonants, F, L, W, R. Number of consonants 4, number of vowels 2. In next, vowels always come together. Together means one letter. This complete bracket considered as a 1. Total number of letters in flower, 5 letters. 5 letters arranged in 5 factorial. Second, here OE, number of vowels 2. 2 vowels arranged in 2 factorial. And denominator always you write repetition of letters in flower. There is no repetition letter 1 factorial. 5 factorial 120. 2 factorial 2. 120 into 2, 240. 240 is right answer. Answer is 240. Second one. Here next same method. Here third one and fourth one, repetition of letters. Here same method, condition, repetition of letters are always right in denominator, that is called permutation. Here next, third example, same technique, same method. A letter, first to find out total number of vowels, only E. Next, number of consonants, L, T, T, R. Next, case 1, 1, 2, 3, 4, 5. 5 letters arranged in 5 factorial. Here E. Next one. Here 2 vowels arranged in 2 factorial. Denominator repetition of letters in letter. E is equal to 2 times 2 factorial. So 5 factorial is equal to 120. Third one answer 120. Same method. Here first target, given what you divide 2 parts. Here first part number of vowels, second part number of consonants. Here case 1 and case 2 together means considered as a treated as a 1 letter. Count total number of letters. 5 letters arranged in 5 factorial. Number of vowels 2. 2 vowels arranged in 2 factorial. Denominator repetition of letters in letter. So repetition of letters in letter. Here E is equal to 2. So T is E is equal to 2 factorial. And T is equal to 2 factorial. A denominator 120. A denominator 2 into 2 is equal to 4. Here 520 into 2 by 4 is equal to. Here 60. Answer is 60. 60 correct answer. Here once again. Here third sub question, third one, letter, repetition of letters in letter, T is equal to 2 times, E is equal to 2 times. Therefore, answer is 60, correct, 60. Okay, right. Last example, here in how many ways can the letters of the word corporation be arranged such that all the vowels always come together? Same method, a corporation, given what you divide 2 parts. First part, number of vowels O, O, A, I, O. Number of vowels is equal to 5. Number of consonants C, R, P, R, T, N. Next method, a vowels considered as a 1 element, one letter. Number of letters 1, 2, 3, 4, 5, 6, 7. 7 letters arranged in 7 factorial. Number of vowels is equal to 5. 5 letters arranged in 5 factorial. A number of vowels is equal to 5. 5 vowels arranged in 5 factorial. And denominator repetition of letters in corporation. Here O is equal to 3 factorial. Next R is equal to 2 factorial. So answer is vowels always come together is equal to 7 factorial into 5 factorial divisible by 3 factorial into 2 factorial. Suppose same question, find out probability. The denominator total number of arrangements in corporation, that is called probability. Here model 1 calculate only total number of arrangements. Model 2 event condition, vowels always come together. In next third model number 3, how many ways the word can be arranged? Vowels always never together. A never together or do not come together, same method. Never together, do not come together, same method. Here first example tiger, second example leader. First example tiger, all the vowels do not come together. I think that concept already completed. Here model 1 minus model 2 is equal to model 3. Here vowels never together is equal to total number of arrangements minus vowels always come together. And first model minus second model is equal to third model. Here first model total number of arrangements in tiger. First you have to calculate total number of arrangements. Total number of arrangements is equal to tiger numerator count total number of letters in tiger. 5 letters arranged is equal to 5 factorial. Denominator repetition of letters in tiger, there is no repetition letter is equal to 1 factorial. 5 factorial by 1 factorial is equal to 5 factorial. 5 factorial is equal to 120. This is equation number 1. Second equation, second method, calculate all the vowels always come together. Next event condition together. Event condition together. In your exam, together type of questions are given. That condition always write one bracket. In tiger, number of vowels only 2, I and E. Next number of consonants T, G, R. Next method, vowels treated as 1 letter. Total number of letters is equal to 4. 4 letters arranged in 4 factorial. Number of vowels is equal to 2. 2 vowels arranged in 2 factorial. And denominator repetition of letters in tiger, there is no repetition letter is equal to 1 factorial. 4 factorial is equal to 24. 2 factorial is equal to 2. 24 into 2 is equal to 48. Equation number 2. Here first equation, total number of arrangements. Second equation, vowels always come together. But our problem is vowels always do not come together. Do not come together is equal to equation 1 minus 2. Equation 1 minus 2 is equal to do not come together. Here 120 minus 48. 120 minus 48 is equal to 720. Vowels do not come together is equal to 720. This is vowels do not come together is equal to 772. Correct answer. Here next same method, same example, calculate probability. Same example, find out probability. Same method, probability is equal to n of e by n of s. Probability is equal to n of e by n of s. N of e, above solution is called n of e 72. N of s indicate total number of arrangements. That is equation number 1, 120. 72 by 120 is called probability. Once again, probability example. Find the probability that all the vowels always never together. The numerator event condition, vowels never together. Denominator total number of arrangements. That is using first equation 120. 72 by 120 is called probability. Only 72 is called permutation. 72 by 120 is called probability. Okay, yes, first one tiger answer 72. Right, next, second example, same method. All the vowels always never together, do not come together. Here first you have to calculate total number of arrangements. Total number of arrangements, numerator 1, 2, 3, 4, 5, 6. 6 factorial. Denominator, leader E is equal to 2 times 2 factorial. 6 factorial 720 by 2 factorial 2. 720 by 2 360. This is equation number 1. Second equation, together condition. Vowels always together. A number of vowels in leader, only 3 vowels E, A, E. Write one bracket. Number of consonants L, D, R. Here first treated as one letter. Total number of letters is equal to 4. 4 letters arranged in 4 factorial. And number of vowels is equal to 3. 3 vowels arranged in 3 factorial. E, A, E. 3 vowels arranged in 3 factorial. Denominator, repetition of letters in leader. E is equal to 2 is equal to 2 factorial. 4 factorial is equal to 24. 3 factorial is equal to 6. 2 factorial is equal to 2. 2 into 12 is equal to 24. 12 into 6 is equal to 72. This is equation number 2. Therefore, vowels do not come together. Equation 1 minus 2. Here 360 minus 72 is equal to answer. Here simple technique. Here method is very simple. Again, if you want to probability, write denominator 360. That is called probability. Here once again, permutation concept. Here problems in permutation. First concept. Here first one, total number of arrangements by using letter concept. Vowels always come together. Second, vowels always do not come together. In next, last concept. Here permutation examples. First one, letter concept. Second, number concept. Third, circular arrangement concept. Fourth, ranking concept. Here permutation exists only 4 methods. And number concept also important. Here first method, letter. Second, number. Third, circular arrangement. Fourth, ranking concept. Four concepts in your exam. Minimum 1, maximum 2 will come from only permutation concept. Okay. Yes, now last one. Here fourth example. A last model using letter concept. Here fourth model. How many ways can the letters of the word optical be arranged such that first one, vowels occupy only odd position or even position. Apply the same method. Second, no 2 vowels always come together. Third, if the word start with P and end with A, start with P, end with A. Start with P and end with A. Here first example, here using NPR. NPR is equal to n factorial divisible by n minus r factorial into r factorial. First one, vowels occupy only odd position, but optical total number of letters 7 letters. 1, 2, 3, 4, 5, 6, 7. Total 7 letters. Here divide 2 parts. First part, vowels. Number of vowels is equal to 3. Number of consonants PTCL. Number of consonants 4. Here method. First example. Vowels occupy only odd position, but number of odd positions, number of odd places in optical 1, 3, 5, 7. Number of odd positions in optical. Number of odd positions in optical is equal to 4. Here NP or N is equal to 4. But vowels, number of vowels is equal to 3. 3 vowels arranged in 4 places is equal to 4P3. Here for NP or indicate number of vowels is equal to 3. 3 vowels arranged in 4 places is equal to 4P3. A second method is blindly applicable only number of consonants. A number of consonants is equal to 4. 4 consonants arranged in 4 factorial. And denominator always you write repetition of letters in optical. There is no repetition letter is equal to 1 factorial is equal to answer. Once again, if the problem is belongs to permutation, denominator always you write repetition of letters. A reason permutation is nothing but repetitions are allowed is called permutation. Your first one answer is 4P3 into 4 factorial. Here 4P3 into 4 factorial is equal to answer. Here vowels all occupy only odd position or even position. Apply the same method is equal to answer. Here second method, no two vowels always come together. Here no two vowels always come together is nothing but here between two vowels one consonant must. The between two vowels one consonant. Reason no two vowels always come together. A number of consonants for PTCL. A condition, event condition between two vowels one consonant is compulsory. First you write all possibilities. Here between two vowels one consonant. Between two vowels one consonant. Between two vowels one consonant. Find the total number of possibilities. A total number of possibilities 1, 2, 3, 4, 5. Total number of possibilities is equal to 5. But number of vowels is equal to 3. 3 vowels arranged in 5 places is equal to 5P3. A second one blindly applicable only number of consonants. Number of consonants is equal to 4. 4 consonants arranged in 4 factorial. So answer is no two vowels always come together is equal to 5P3 into 4 factorial. And also denominator always write only repetition of letters in optical. Here there is no repetition letter. So answer is 5P3 into 4 factorial. That is second question answer. Okay. Yes, here last one. Last one easy method. If the word start with P, end with A. Here start with P, end with A. A total 7 letters. 1, 2, 3, 4, 5, 6, 7. Here start with P, P 1 letter, 1 factorial. End with A, 1 letter, 1 factorial. Middle 5 letters arranged in 5 factorial. So answer is 1 factorial into 5 factorial into 1 factorial is equal to 120. 120 is equal to answer. Here once again, here models in permutation by using letter concept. First model, total number of arrangements. Second model, vowels or consonants always come together. Third model, vowels do not come together or never together. And next model, here model number 4, here vowels occupy only odd position or even position. No two vowels always come together. No two consonants always come together. Particular letters are always come together. All are using same technique. The last one easy method. If the word start with P and end with A. Last model is very simple. But all these questions, all these models, denominator always you write a repetition of letters. Otherwise is not a permutation. Permutation definition, repetitions are allowed is called permutation. That condition always write in bracket A. That is always write in bracket. And the next one probability in permutation. And first we calculate permutation of a given statement. Next write denominator total number of arrangements. If write denominator total number of arrangements, that problem automatically convert into a probability. Then at a time permutation completed and also probability completed. Okay.
Like, share and subscribe. Hit the bell icon for more updates.